Let's talk about solving a triangle. Now, solving a triangle is just like solving an equation. To solve an equation, we want to find the unknown value in the equation. Okay. To solve a triangle, likewise, we want to find the unknown values in the triangle. Now, in the triangle, in this chapter, we'll stick to this convention. We have the triangle with angles A, B, and C in capital letters. Angle A will be pointing opposite to the side A in small letter. B will be opposite to side B in small letter, and angle C will be opposite to side C, right? So each side will be named like the opposite angle. So now altogether there are 6 unknowns. 6 unknowns being 3 angles and 3 sides. To solve the triangle, we need 3 of them. We need to know 3 of them. Alright, except AAA, right? We'll see later. If you have 3 angles, it's actually not 3 pieces of data, but just 2. Because if you know any 2 angles, then automatically you get the third one. So AAA is in fact not 3 pieces of information. But anyways, we need 3 independent pieces of information and find the other 3. Alright. So what are the 3 pieces of information? It can be like all the size. It can be like triple S. It can be ASA or AAS. Alright. It can be SAS. It can be SSA. Alright. These are the situations that you have 3 pieces of information. Once you have the 3 pieces of information, we can find the other 3. Alright. Now there are 2 sets of tools that we can use to find the unknowns in the triangle. The first set is what we call the Sine Formula, or the Sine Law, or the Law of Sines. Alright. The Sine Formula says that if you have sine A divided by A, the angle divided by the opposite angle, the sine value of the angle divided by the opposite length, alright, sine B over B is sine C over C, alright. Now ABC must be in the same triangle, alright. It does not apply across triangle. It must be in the same triangle, alright. So it's easy to state. Sine A over A is sine B over B is sine C over C. So every time we just use one pair, alright. Maybe this pair, alright, or maybe A and C, alright. So this is the sine formula. Now, sine formula is used when you have the ASA or AAS situation. They are the same, 2 angles, 1 side, alright? These are the cases, most notably, you will use sine formula. And then we have 2 versions of the cosine formula, or the cosine law, or the laws of cosine, alright? The cosine formula, the first version is the SAS version. SAS version, you know 2 sides. Say for example, you know A and B, alright, you know A and B, and then you know angle C, alright, then we have an SAS situation, right? We can apply the cosine formula. If in the SAS cosine formula, it goes C square is A square and B square minus 2AB cosine C, alright? This is the SAS cosine formula. If you swap A, B, and C, you will have different versions of the cosine formula. But they are just the same thing, only that they have the cyclic naming of the A, B, and C. We have A square will be B square and C square minus 2BC cosine A. Alright? So these are the cosine formula for the SAS version. Now, rearranging the blue sets, we have another set of cosine formula that works for triple S condition. Alright, say if you rearrange the first one, we have cosine C equals to A square and B square minus C square divided by 2AB, right? You just rearrange the terms in the first one, and then you can arrive at this one. And likewise, for cosine B and cosine C, we have similar formula. That would be now the way to remember it. Cosine B will be the one that you do not have. You do not have A and C, so you have A square and C square, and then you subtract the line that is opposite to the angle. Okay, so cosine B will be minus B square, and then divide by 2AC. And finally, cosine A will be that would be B square and C square minus A square dy by 2bc. Alright. So on the left hand side you have all a, b, c, the three sides. Alright. And then you want to find the cosine of that angle. So that is when you have the triple S. You have a, b, and c. Then you can use this cosine formula. You have a, b, and c. Alright. Or in the case of the SAS situation, if you have angle A, angle B, you have line A, line B, and angle C, or you have B, C, and angle A, or you have A, C, and angle B. These are the SAS situation. I refer to the diagram. If you have A, B, and angle C, this is an SAS. If you have B, C, and angle A, that would be another SAS. Right? So these are the situations we use cosine formula. All right. Sine formula to be more angles than sides. ASA or AAS, more angles, we use the sine formula. More sine than angles, SAS or triple S, we use cosine formula. There are two sets of cosine formula, but you can transform from one set to another. Plus, if you do it on the calculator, the blue set is you're using the calculator is formula 02. On the Casio calculator is on formula 02, alright? You input the values A, B, and C respectively. Angle A, line A, line B, and angle C, then you can immediately get the value of the opposite side. Alright, you can use the calculator. Using the Casio calculator, you can have the built-in formula. Alright? Now let's start with one simple example. So suppose you have a triangle that goes like this. We have triangle. This is 6. This is 7. This is 50 degrees. So let me ask you two questions. What is this sine? What is this line X? And what is this angle theta? Okay. So let's do this. All right. So x squared will be 6 squared and 7 squared minus twice 6 times 7 times cosine 50 degrees. Alright, that is the cosine formula. You can do it on the calculator, right? But now there are some some common mistakes I want to remind you. Number one, cosine formula. Most people were making mistakes in this plus and minus. Some people mistook it as a plus. Alright, in fact it should be a minus. And then some people forgot the 2. Alright, so you just put a squared and b squared minus ab cosine c. In fact, there should be a 2 here. Alright. Now, normally people are not making mistake in the sine formula, the green part. The green part is simple, so everyone is good at this one. Alright, it's very difficult to make mistake in the sine formula, right? But in the cosine formula, people were making mistakes in this red part. Alright, so pay attention to this one. It's a subtraction. Alright, cosine c, if it is negative, then it turns out positive. But the formula itself is a minus a squared and b squared minus 2bc. Don't forget the 2. Alright. Now, as for the purple part, it's just a transformation of the blue part. So once you get the blue part, you can just rearrange the terms to arrive at the purple part. You don't have to specifically remember the purple part. Alright, unless you're very poor at those transformation of terms, that would be another problem. Alright. So these are the two common mistakes. Number one is the negative. Number two is the number 2, right? The red part here. Now the second mistake in doing this is people will just write down the formula, and then she will secretly use the calculator formula 02 to get the answer instead of just work out the the calculation. So I input 6, 7, and the answer is 50. So this line will be 5.57. Alright. So this is her answer. X will be 5.57. Now, if you put the answers like this, you will not get the answer. If you put your solutions like this, you will not get the answer mark. Do you know why? Can you spot where the mistake is? The original left-hand side was an x squared. Alright, so now if you put something like this, that means x squared is this one, and this one equals to 5.57. In fact, it is not. In fact, it should be x equals to 5.57, right? Do not miss this one. If you miss this one, right? The meaning is x squared is 5.57, all right? Because you continue on from x squared, the original left-hand side, you never change it. So you should put back the x here so that x is 5.57, all right? So far, so good, right? That is the Sas cosine formula. Sas cosine formula, isn't it? Okay? So let's find theta. Let's find theta. Now, there are two ways to get theta, right? Let's find theta with sine formula. And then let's find theta with cosine formula. Now we got x. We can do it in both ways, right? Let's try cosine formula. Cosine formula, we have cosine theta is 7 squared plus x squared minus 6 squared divided by 2 times 7 times x, alright? So that would be some calculator work. So theta will be 55.63, alright, degrees, right? Once again, do not miss the theta here, alright? If you just do it like this, that means literally cosine theta is 55.63, which is wrong. It should be theta equals to 55.63, alright? If you lose one answer mark in this case, that would be, very unfortunate. Alright, so that's from the cosine formula. Alright. Now let's try that for the sine formula. From the sine formula we have well, let's see what is it. We have sine theta over 6 equals to sine 50 over x. Can we do this, right? Sine theta compared to 6 is sine 50 compared to x, right? This is how sine formula works. So once again, we do it on the calculator. Okay, so the calculator shows it is 55.61 degrees, alright? Now you see there is a tiny difference between these two answers. So how do you explain the difference between these two answers? How do you explain the difference between these two answers? Alright. There is a difference between these two answers because in my calculation I use 5.57 in my calculation. Alright, I use the round value for the calculation. Right, that's the problem in this one is what we call a premature rounding. We round off the numbers too early. Alright, we round off the numbers too early. Now, if you go back and look at x, the answer of x should, if you have more decimal places, if you allow more decimal places, x should be 5.5683 if you allow for 2 more decimal places, right? And if you use that extended accuracy number into the calculation, we'll see a different result. If I use a different value, I will have theta equals to 55.63, right? Try that on the calculator. If I take x is 5.5683, alright? In the first one, I take x is 5.57, alright? So you have different result. Let's check that on the cosine formula, on the cosine part, right? If I use a more accurate value for the x, the theta come up the same, alright? The first one is when I do it on the calculator, I use x is 5.57. The second time I use a more accurate value, 5.5683, alright? So now these two answers, they agree with one another. Alright, these two answers, now they agree with one another. That is because at the first time when I did it with a result not accurate enough. Alright, because I commit the error of premature rounding. Right, I committed the problem of premature rounding. I round off the value of x too early, too much. Alright, so it might affect the result. Namely, in this time, this is not as accurate as is enough. Alright, but if you keep 2 more decimal places, and you take the intermediate result to further calculation, the result will align each other better. Right, so to avoid premature rounding, by taking, usually that would 2 decimal places would be enough, right? By taking 2 more decimal places in the intermediate results. right? There are some intermediate answers, right? To avoid this one, to avoid this type of error, you can try to take two more. If the question requires 2 decimal places, you take 4 decimal places, right? In that case, you can avoid premature rounding. If you know how to use the calculator, the best way is not to round at all. You store the value in the calculator and keep using the store value to do that. Okay, so that is the part 1 of the solving triangle topic. Distinguish the sine formula and cosine formula, and what are the situations you use the sine formula, what are the situations you use the cosine formula.